Hey guys! Welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss zeros of polynomial function using rational zero theorem. So, let's go! The rational zero theorem. The rational zero theorem states that if p of x is a polynomial with integer coefficients and p over q is a zero of p of x, then p is a factor of constant term and q is a factor of the leading coefficient. So for example, let's have if negative 2 over 3 is a zero of p of x equals 6x squared plus 7x plus 2, then 2 is a factor of constant term 2 and 3 is a factor of the leading term 6. So we use the rational zero theorem if the leading coefficient of the given polynomial function is not equal to 1. So let's have this example. Find the zeros of p of x is equal to 12x cubed minus 16x squared minus 5x plus 3. Since the leading coefficient is 12, then we're going to use the rational zero theorem. And if you want to find the zeros of this, you're going to follow the same steps with finding the zero using integral zero theorem. So you have here, step 1 is to arrange the polynomial in decreasing power of x, use zeros to place in any missing term, and then equate to 0. If the polynomial is in the factor form, we will proceed to step 5. Step 2 is to determine the degree of the polynomial to determine the maximum number of roots that we are going to have. Step 3 is to list down all the possible zeros using the rational zero theorem. Step 4 is to use synthetic division, long division, or factor theorem to determine the roots of the polynomial equation. So for this one, we're going to use synthetic division. And step 5, if the polynomial is in the factor form, use the zero product rule. Okay, so now let's try to solve it using our steps. So step 1 is to arrange the polynomial in decreasing power of x. So since it's already arranged, we're just going to equate it to 0. So we will have 12x cubed minus 16x squared minus 5x plus 3 equals 0. Step 2 is to determine the degree, and the degree of this polynomial is 3. So therefore, we're going to look for maximum of 3 zeros. Step 3 is to list down all the possible zeros using the rational zero theorem. According to the rational zero theorem, if p over q is a zero of p of x, then p is a factor of your constant term and q is a factor of your leading coefficient. So therefore, we have to get the factors of our constant term, which is our p, on our example, which is 3. So we will have positive negative 1 and positive negative 3. And the factors of leading coefficient, which is our q, and on our example, these are the factors of 12, which are positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. And to get all the possible zeros, all we have to do is to make a number composed of p over q, and we will have the following. So the first one is positive negative 1 half is actually from the 1 on your p over 1 from your q. Then we have positive negative 1 half, so that's 1 from your p over 2 from your q. And then we will have positive negative 1/3, positive negative 1/4, positive negative 1 over 6, and positive negative 1 over 12. Then we are going to do the same with 3. So the person will become 3 over 1, which is positive negative 3. Then we will have 3 over 2, positive negative 3 over 2. Then 3 over 3 is 1, so we don't have to write it since we already have 1. Then we have 3 over 4. Then 3 over 6 is 1 half. And 3 over 12 is 3/4. Since we already have 3/4, we don't have to write it again. So these are the possible zeros of our polynomial function. Now we can proceed with step 4. So we're going to use synthetic division. So we set up our synthetic division. Our aim is when we apply the synthetic division, the last digit on the third row should be 0. So we're going to pick a number from our possible zeros, put it on the synthetic box. So let's have 1, then apply the synthetic division and hope that we will have 0. So bring down 12, multiply, that's 12, add, that's negative 4. multiply, that's negative 4, add, it's negative 9, multiply, it's negative 9, add, you will have negative 6. So since this is not 0, then it is an error. So what we're going to do is to perform another synthetic division, and we're going to pick a different number from our possible zeros, and we apply the synthetic division and hope that our last digit on our third row will become 0. So this time, let's try negative 1/2. So bring down 12, multiply, that's negative 6. We add, that's negative 22. Negative 1/2 times negative 22 is positive 11. Add, that is positive 6. Negative 1/2 times 6 is negative 3. 3 plus negative 3 is equal to 0. So since it is 0, then negative 1/2 is one of the zeros that we're looking for. So all we have to do now is to write the remaining expression in quadratic equation. So that will give us 12x squared minus 22x plus 6 equals 0. Then we're going to look for the factors of this quadratic equation. So we will have 3x minus 1 times 4x minus 6 equals 0. So since it is already in the factor form, we will proceed with the step 5, and we can now use the zero product rule. So we equate 3x minus 1 to 0. Then we solve for x, we will have x is equal to 1/3. Then the other factor is 4x minus 6 is equal to 0. Then we solve for x, we will have x is equal to 3/2. So all we have to do now is to combine all the zeros, which are zeros, negative 1/2, 1/3, and 3/2. Okay, so now let's have another example. Find the zeros of p of x is equal to 32x raised to 4 minus 40x cubed plus 4x squared plus 10x minus 3. So step 1 is to write in standard form and equate it to 0. Since it's already arranged, you simply equate it to 0. So we will have 32x raised to 4 minus 40x cubed plus 4x squared plus 10x minus 3 equals 0. Step 2 is to determine the degree. So the degree is 4, so therefore we're going to look for maximum of 4 zeros. Step 3 is to find the possible zeros. So first, we get the factors of our constant term that will give us the p. So we will have factors of negative 3, positive negative 1, positive negative 3. Then we were going to look for the q, which are the factors of our leading coefficient 32. So we will have positive negative 1, positive negative 2, positive negative 4, positive negative 8, positive negative 16, positive negative 32. Then all you have to do is to get your p over q, and that will give us our possible zeros. So the possible zeros are positive negative 1, positive negative 1/2, positive negative 1/4, positive negative 1/8, positive negative 1/16, positive negative 1/32, then positive negative 3, positive negative 3/2, positive negative 3/4, positive negative 3/8, positive negative 3/16, and positive negative 3/32. We can now proceed to step 4, which is use a synthetic division to find the zero. So we set up our synthetic division, and our aim is to have the last digit on our third row equals 0. So we pick a number from our possible zeros. So let's have negative 1/2. Then we apply the synthetic division. So bring down 32. Then multiply. So that's negative 16. Add, that is negative 56. Multiply, that's positive 28. Add, that's 32. Multiply, you will have negative 16. Add, that negative 6. Multiply, you will have positive 3. Add, that is 0. So we already have one of our zeros, which is negative 1/2. So since we're still going to look for 3 more zeros, we're going to perform another set of synthetic division. So we're going to pick another number from our possible zeros. So let's have 1/2. Then apply the synthetic division. So bring down 32. Multiply, that's 16. Add, that's negative 40. Multiply, that's negative 20. Add, that's 12. Multiply, that is positive 6. And you will have here 0. Since this is another 0, then 1/2 is another zeros of our given polynomial function. So after this, we can now just simply write our expression in quadratic equation. 32x squared minus 40x plus 12 equals 0. If you want, you can simplify it first by dividing both sides of the equation by 4, and we will have 8x squared minus 10x plus 3 equals 0. So this is to make the numbers smaller, so it will be easier to find the factors. All we have to do is to find the factors of this quadratic equation. So we will have 2x minus 1 times 4x minus 3 equals 0. We use the zero product rule. So we will have 2x minus 1 is equal to 0. Solving for x, we will have 2x equals 1. Divide both sides by 2. Then x is equal to 1/2. Then the other one is 4x minus 3 is equal to 0. Then solving for x, we will have 4x equals 3. Then divide both sides by 4. Then we will have x is equal to 3/4. So the zeros are negative 1/2. 1/2 multiplicity of 2 since we have here repeated zeros. Then 3/4. Okay, so let's have our last example. So find the zeros of p of x equals 6x cubed minus 13x squared minus 4x plus 15. So first, we arrange it, then equate it to 0. So we will have 6x cubed minus 13x squared minus 4x plus 15 equals 0. Then the degree is 3, so we're going to look for maximum of 3 zeros. Then after this, we're going to look for the possible zeros. But first, we have to get the factors of our constant term, which is 15. Then get the factors of our leading coefficient, which is 6. All we have to do is to list down all the possible zeros using the rational zero theorem. So forming numbers from P over Q. So we will have the following numbers. Then after listing the possible zeros, we can now use the synthetic division to find the correct zeros. So set up the synthetic division. Our aim is to have the last digit on the third row equals zeros. We're going to pick a number from our set of possible zeros. So we can have negative 1, then we're going to perform the synthetic division. So bring down 6, multiply, that's negative 6, add, that's negative 19, multiply, that's positive 19, add, you will have 15, multiply negative 15, then you will have 0. So since the last digit on the third row is equal to 0, the negative 1 is one of our zeros. So all we have to do now is to express the remaining expression in quadratic equation. So we will have 6x squared minus 19x plus 15 equals 0. Then look for the factors of this quadratic equation. So we will have 2x minus 3 times 3x minus 5 equals 0. Then proceed to step 5, which is zero product rule since it is already in the factor form. So we equate 2x minus 3 to 0. Solve for x, we will have 2x equals 3. Divide both sides by 2. Then x is equal to 3/2. Then the other one is 3x minus 5 equals 0. So we solve for x. We will have 3x equals 5. Divide both sides by 3. Then x is equal to 5/3. So the zeros are negative 1, 3/2, and 5/3. Okay, so that's it. We're done. Thank you for watching and hope you have learned something from this video.